My name is Pablo Morales, Communications Manager at Sustainable Innovation, and also leading the dissemination and communication task within the STOPP projects, which is a European initiative focused on developing strategies to prevent and reduce plastic packaging pollution from the food system. And today with me is our project coordinator, Milad from VTT, which is a consultancy in Finland. He will deliver us a session focused on food packaging recycling, and he will explain the challenges and opportunities. Before giving the floor to Milad and introduce himself, I would like to let him know the audience that this is a recording session, so the presentation will be available in the upcoming days. Also, we want to make this session as much as interactive as possible, so you have the possibility to enter any kind of questions, comment, or curiosity that you may have during the presentation by using the chat function in the Zoom application. So feel free to enter any kind of curiosity you may have. And rather than that, I think that's all from my side. I will be Milad moderating the session and reading the question in case we have. But for now, I think it's time to giving you the floor. Maybe you can start by introducing yourself, and from my side, I just give you the floor and feel free to start the webinar. Thank you.
So thank you very much, Pablo, for the introduction, and good morning or good afternoon, everyone. It's a pleasure to be here today. My name is Milad Mosallaei. I'm a research scientist in VTT Technical Research Center of Finland. My background is my master's studies is in polymeric materials, focusing on polymeric materials and analysis, and my PhD is in printed electronics. I am also the coordinator of EU STOPP project. The title of our webinar today is Food Packaging Recycling Challenges and Opportunities. Here is the agenda of the presentation. First, I briefly introduce the company that I am from. Then I will give you an overview of the STOPP project as the whole package. Then we review some challenges that currently we have in food packaging, and obviously the solutions and opportunities that are provided by the STOPP. And then I will summarize our discussion, followed by a final takeaway. And at the end, Q&A. I try to make the presentation not too much into detail, because I know that we have people with different level of knowledge about the field. So I try to make it in a way that it's quite easy for everyone. And in case that you have any question and you need more details, please feel free to contact me by email so I can provide the required information. Yes, about the company. So as I mentioned, I'm from VTT Technical Research Center of Finland. We are a visionary company, a research, development and innovation partner for business and society, and we are one of the Europe's leading research organizations. Our company is a multidisciplinary international research and technology organization with around 2,400 experts in different fields. We are actually a state-owned government, and we enable future innovation through our leading professionals and research environment. Our main mission is to promote the utilization and commercialization of research and technology in business and society. As you could see, we have 6 offices in Finland, with which our headquarters is located in Espoo. And I'm from Tampere office. Here, I would like to discuss about plastic processing and characterizations at VTT, polymer pilot, which we have in VTT. polymer processing and recycling infrastructure for experimental development of polymer and composite technologies. The key research equipment are for polymer compounding, reactive extrusion, polymer foam technologies, multi-layer film extrusion, coating and lamination, injection molding, mechanical plastic recycling, and material characterization. Facilities enable research and innovation from already lab to pilot scale. This infrastructure, as I mentioned, is located in Tampere. The chemical laboratories enable carrying out wet chemical reaction, polymerization, and extraction in glass and steel reactor. Our modern research and development laboratories include analytical equipment, material characterization, material properties, and spectroscopy. Let me briefly introduce the STOPP project. STOPP stands for Strategies to Prevent and Reduce Plastic Packaging Pollution from the Food System. It is a Horizon Europe Research and Innovation Action funded by the European Research Executive Agency. The project officially kicked off in January 24 here in Tampere, and runs until the end of this year, end of 2026. Our focus is on developing science-based and practical solutions to reduce plastic packaging pollutions, covering prevention, better design, reuse, and improved recycling. The project operates under the Zero Pollution Call, and it brings together multiple partners across Europe to address environmental impacts, regularity challenges, and innovation needs in the food packaging value chain. This fact sheet simply summarizes the formal project details, its number, call topic, and duration. And under this call, there are two projects more than us. There is another project called Magno, which is actually the sister, our sister project, and we have made clustering team with very good collaboration between these two projects about the findings, solutions, etc. Regarding the consortium, we have 14 partners in the project, in which five of us are from Finland, including VTT Technical Research Center of Finland, which is actually the coordinator and coordinator of the project. University of Vaasa, HSY, Ekokumppanit, and Pirkanmaan Jätehuolto. National Institute of Biology and National Institute of Chemistry are from Slovenia. Green Delta, Braskem, and Remondis are our partner from Germany. PRE is our Belgian partner, Veolia from France, and Sustainable Innovation Europe, the organization of Pablo, is our partner from Spain. And last but definitely not least, Recircle from Switzerland. I hope I mentioned everyone here. So about the STOPP project, the overview of the project. STOPP is actually an initiative to revolutionize the way we approach food packaging by working with all the stakeholders in the value chain. The concept here is to stop the way of operations that lead to environmental pollution, use of unsustainable virgin fossil resources, excess use of resources, insufficient use of products, high level of generated plastic litters, incineration, and landfilling, and produce strategies for food plastic packaging, circularity within the categories of 5Rs. So 5Rs are refuse, reduce, redesign, reuse, and recycle. Having said that, we aim to create circular strategy for plastics by analyzing waste, improving recycling, designing sustainable business models, and studying consumer behavior. The key STOPP objectives are listed here. We have 5 key objectives. Analyzing the plastic impacts on diverse ecosystems. So more precisely, we create a report and gap analysis on how littered plastics from food packaging can affect the environment and ecosystem. Supporting the transition of key stakeholders toward alternative circular solutions in food packaging systems by identifying their needs and motivations and creating practical tools. Developing future fit sustainable business model blueprint for packaging value chain, including new materials, recycling, and reuse cases. Increasing recycle from already collection and sorting practices. So here, for instance, we are producing recommendations, practical recommendations to improve collection and sorting. And consumer studies and awareness campaign to engage over 10,000 European consumers in topics such as reusable packaging or behavior change to improve awareness, acceptance, and uptake. So STOPP's objectives range from ecosystem impact studies to design for circularity and developing business models and advancing safe recycling technology. This cross-disciplinary approach ensures that solutions are technically possible, environmentally beneficial, and socially acceptable. So, as we know, food packaging is essential for food safety, hygiene, and increasing shelf life. But on the other side, it's also one of the hardest waste stream to recycle. And what makes recycling of food packaging difficult? So, contamination. They have low level of contamination. Then they have complex structures like multi-layers. There are variability in collection system, and then limited feasibility of reusable packaging and packaging and consumer behavior challenges. Of course, there are a lot of other reasons that makes the food packaging difficult for recycling. But for instance, the economic side or degradation of material during the processing and a lot of other stuff. But I thought that maybe today we can just focus on these few challenges, what they are, how they are created, and what are the solutions that we bring from STOPP project. When we talk about contamination in food packaging, the biggest issue that many packages still contain leftover food, oil, sauce, or liquid when they enter the recycling streams. On the top of that, the packaging itself carries inks, adhesive coatings, and chemical additives that were originally added for branding, sealing, or improving performance. All these substances stick to the material and make it much harder to recycle cleanly. Contamination reduces the quality and safety of recycled plastic. The project assessment of EU collection and sorting systems shows that contamination affects the efficiency and accuracy of sorting, limiting the recovery of clean monomaterial streams and reducing the recyclability of plastics. Contamination introduces chemical complexity like NIOS. Contamination like NIOS, inks, and additives, they introduce chemical complexity. Printing labels, inks, and other surface treatments also add chemical contaminants that require complex and energy-intensive decontamination processes. So about NIOS, if for those of you who are not familiar, NIOS is non-intentionally added substances. They are chemical compounds present in food contact materials like plastics or papers that they were not originally added intentionally, but appear through raw material impurities, manufacturing byproducts, or degradation. The problem is that these NIOS pose migration risks to food and require risk assessment per European regulations. Contaminants continue to waste heterogeneity, which is already one of the core barriers for mechanical recycling identified in the project. Under the EU regulations like food contact plastics and PPWR, the presence of contaminants directly limits which waste stream can be recycled back into food packaging, which requiring strict control and testing. So, what about the complex packaging structure? What challenges we can get from this particular one? So many food packages are multi-layered to achieve functions like oxygen barrier properties. These layers are often incompatible in recycling systems. Labels and inks further interfere with like sorting and reprocessing. They are difficult to sort due to the mixed materials. The project assessments of collection and sorting show that mixed material packaging streams, especially multi-layer structure, reduce sorting accuracy because current systems like NIR or density separation cannot reliably identify and separate layers and embedded components. Then they are not compatible with existing recycling streams. So multi-layer structures are not compatible with the standard mechanical recycling because imagine that in one simple packaging, we have different polymers. They melt, degrade in different conditions, and makes the reprocessing of them quite difficult. At some temperature, they are not degraded. Some of them are not degraded, while this is degradation temperature for others, which leads in low quality of recycling. Multi-layers increase heterogeneity of the waste stream. These structures significantly contribute to this heterogeneity, making it harder to achieve like clean monomaterial stream that we require for high quality recycling. Decontamination becomes even more complex and less efficient because even with advanced decontamination units, multi-layer structures prevents cleaning because contaminants can reside between layers, different layers, and migrate differently depending on the type of polymer. These packaging and these structures are often designed for performance, not recyclability. Many of these multi-layer structures are optimized for barrier performance, like oxygen or UV, but not for end-of-life recyclability. Incompatible layers cannot be separated economically, so causing the entire package to fall into non-recyclable category. Then regulatory alignment and certification become harder. When packaging is made from complex multi-layer and multi-material source structures, it becomes much more difficult to meet today's like strict regulatory and certification requirements, especially for food contact safety. Regulations expect recyclers to prove that recycled materials are clean and, of course, safe and free from substances that could migrate into food. But when packaging in these structures contains many layers, ink, adhesive coating, and additives, it's harder to remove all contaminants and to demonstrate compliance. Uh, also, the recycling process becomes less predictable, and the final material often fails to meet the purity level required for certification for specifically food grade use. In practice, this means that multi-layer packaging often drops out of high-value recycling loops because it simply cannot meet the regulatory threshold that single material packaging can achieve. And the other challenge that we have is the collection system variability. Across Europe, collection systems differ widely. Even within the same country, regional collection methods vary. These differences influence contamination, sorting efficiency, and output quality. In STOPP, we map and compare these systems to identify the best practice, which I will explain a bit later. Variability affects the composition and purity of collected plastic waste. For instance, in the project work package 5, we understood that the composition of collected PP rigid packaging varies significantly depending on the local collection method, which directly affects the level of contamination and the recyclability of the material. Then forbidden items differ between regions, which increasing inconsistency. The project collection assessment identifies region-specific list of forbidden items in plastic packaging streams, creating inconsistency and increasing sorting challenges at recycling facilities. Then this inconsistent collection leads to unpredictable feedstock for recycling experiments. For instance, in Work Package 5, sampling plans and experiments had to account for major differences between partner countries, which shows that the variability in collection system leads to highly inconsistent feedstock, complicating optimization of sorting and decontamination process. And large variation between home separated and post separated system. The project evaluates both home separated, which means citizens or like users sort at home, and post-home separated, mixed waste sorted later systems. These two models lead to major differences in contamination level, polymer mix, and overall packaging quality, all of which prevents recycling efficiency, or let's say lowers the quality of the recyclates. Then this variability impacts the ability to generate uniform, high quality recyclates because recyclability and decontamination performance depend on feedstock consistency, and system variability makes it difficult to generate comparable uniform quality recyclates, especially for food contact applications. Then this challenge creates issues for cross-EU harmonization and policy recommendation. So creating EU-wide harmonized policies becomes challenging since the starting conditions are not the same across regions, and the data collected with the consortium reflects strong structural differences rather than a single coherent system. So limited practical feasibility of reusable packaging systems. So maybe it was better that I somehow changed the order of this slide, but anyway. This challenge means that reusable packaging is conceptually very attractive, but at the same time very hard to implement in real life. Durability and safety limitation. So reusable containers must withstand many cycles of washing, eating, carrying, and handling, and at the same time, they don't get breaking, warping, or becoming unsafe. However, most current reusable packaging lose mechanical strength over time, becomes scratched or damaged, and may fail hygiene requirements after repeated use. This makes large-scale reuse technically unreliable. Then operational and logistic complexity. Basically, reuse systems require washing infrastructure, return points, transport loops, tracking system, clear routines for business and consumers. In practice, these are often expensive to run, hard to coordinate, causing low return rates, which makes reuse system operationally difficult to sustain. Then consumer behavioral consumer behavior barriers. In the work package 7 of the project, we show that consumers often do not return containers consistently. They are unsure about hygiene and find reuse inconvenient. Misuse or improperly clean containers. Without strong participation, reuse system cannot function efficiently. And then the next challenge is the consumer behavior. Consumer confusion continues to be a barrier. Although the large STOPP study of 5,760 participants across Finland, France, Poland, and Spain shows that people consistently perceive recycling and reuse in positive cognitive, emotional, and social terms. And obviously, general trash and especially littering carrying more negative meanings. These clear differences highlight the need for communication strategies that build on positive association and directly address misconceptions. Contaminations and misuse originate largely from consumer habits. The project highlights that contamination originates in use and misuse of packaging. And this is significantly affected by consumers. Incorrect disposal, not emptying or cleaning food packaging, and mixing non-recyclables into recycling streams all lowers the quality of collected plastics. Consumers generate heterogeneous waste stream through inconsistent sorting. Variability in how people sort waste contributes to heterogeneity of plastic packaging waste, which is one of the core barriers to effective recycling identified in our project. Mixed polymers, food residues, and wrong distorted items make it harder to achieve clean monomaterial fractions. Then, misunderstanding or lack of awareness about correct disposal. The project system and stakeholder analysis show that many consumers lack clear understanding of what is recyclable, which packaging belongs where, and how to prepare it. For example, emptying food, removing labels. This directly increases contamination levels and reduces recycling efficiency across EU regions. Then regional differences in consumer habits interact with collection system variability. Consumer behavior challenges are increased by the fact that collection systems differ across regions, meaning consumers follow different rules and habits. This inconsistency lead to non-standardized disposal pattern affecting the quality of the sorting input. Low engagement in proper sorting reduces availability of high-quality recyclates. When consumers fail to sort correctly or mix materials that should be separated, the available recyclate quality decreases, directly affecting the feasibility of producing food-grade recycling plastics. Then consumer-driven littering and improper disposal add environmental impacts. The work that my colleagues at Work Package 2 handled emphasizes that consumer littering increases environmental pollution and complicates recovery of plastic for circular loops. Littered items often degrade, fragment, or become contaminated, making them unusable for recycling. Then behavioral barriers hinder adoption of reusable packaging system. In the project exploration of reuse system, consumer misuse is a known risk that can compromise safety and functionality. So, in a nutshell, all these challenges that I mentioned, they are connected together. So now that I mentioned some challenges that we face in recycling of food packaging, I would like to highlight the opportunities for improving recycling and design for circularity from STOPP point of view. So these opportunities are safe food contact recyclates, monomaterial packaging, STOPP evidence-based recommendations to improve collection systems, reuse systems innovation, societal engagement, and behavioral shift. About the safe food contact recyclates. Here we show how the project produced safe, high-quality PP recyclates for food contact applications. Our decontamination setup follows the full Recyclats mechanical recycling protocol. So Recyclats is actually a European-wide system that evaluates and certifies the recyclability of plastic packaging. And it requires grinding, washing, density separation, wind sifting, extrusion, and pellet analysis. Each step is evaluated for how effectively it removes NIOS, fogs, inks, and adhesive residues, and surface-borne contaminants, bringing the recycled PP closer to EU food contact threshold. And yeah, if I just show this picture, here is the protocol that we use for decontamination of our materials. So it has different stages. So we get the feedstock, then we use sorting like NIR, density separation, and then washing, which is with cold, hot, and detergents, air electriation, and wind sifting, and super cleaning, and then extrusion and melt filtration. So when we reach to this point that already material is in the flakes status, we use the super cleaning oven that we develop in VTT. So what is interesting about our super cleaning contamination unit is that we use flakes, not pellets. Flakes have more, let's say, surface area, and it makes it easier to for the oven to reach the contamination and somehow clean the volatile and semi-volatile compounds. And we have better control on how the super cleaning oven works. And after each of these steps, we use series of analyses like to understand the NIAS and other parameters. And after we get the result, we somehow moderate and optimize the parameters for decontamination. And then about the monomaterial packaging. So in the project, we are developing PP-based monomaterials with improved oxygen barriers. This can reduce complex multi-layers while staying compatible with recycling. This is a key step toward design for recycling. Simplifies packaging design and reduce material complexity. So monomaterial PP design allow elimination of secondary layers, tie layers, and adhesive, resulting in similar structures with fewer components. This improves sortability and reduce contamination risk during recycling. Then it improves recycled quality and melt purity. Since monomaterial packaging retain a uniform polymer matrix, recyclates have higher melt purity, fewer defects, and more predictable processing behavior, which benefiting both recyclers and converters. Then it aligns strongly with EU regulatory drivers like PPWR. Monomaterial packaging directly addresses future mandatory recycling performance grades and supports targets that effectively phase out complex non-recyclable structures. Then it improves circularity by maximizing compatibility across the value chain. So monomaterial packaging benefits sorters, so they have easier NIR, for instance, NIR identification. For recyclers, the predictable PPS stream, higher yields, and converters, consistent recyclates for new packaging. And brand owners, better compliance with PPWR and recyclers. Then reduces environmental impact through light weighting and right sizings. Monomaterial solutions allow optimizing film thickness to the minimum required for food protection, reducing resource use and avoiding over-engineered multi-layers. So about this image, the monomaterial work that we are doing in STOPP focuses on two polypropylene PP grades. Why? Because PP is a major material used in food packaging. PP's main limitation is its low oxygen barrier performance, which often leads to multi-layer or multi-material structures that decrease recycling quality. These tasks aim to improve the OTR, which is oxygen transmission rate of polypropylene, by adjusting in two different ways. So the root one is processing parameters. And in here, we have the base polymer. And then we use like cast extrusion by axial stretching to adjust the parameter and fine-tune this OTR and other properties that are needed. And the second one is compounding. Again, we have the PP as the base polymer, but with some additives like nucleating agents, food-grade talc, or plasticizers. This is also the second route. As you could see, the first one is completed, but the second one is at the moment ongoing. So, as I mentioned, one of the challenges is variability in collection and sorting. So, collection practices vary widely across here in Europe. So, we have home separated versus home separated or mixed collection. Different contamination levels, different sorting infrastructures. This variability makes it difficult to obtain consistent, high quality, for instance, PP feedstock for recycling. This is a challenge that in STOPP, we convert this challenge into opportunity for system level improvement and turn the differences between European collection system into practical knowledge, tools, and policy guidance. So in this image, you see two simplified flow diagrams showing how the project compared real waste collection systems. On the left, the image, or let's say the diagram represents Finland. So where two regions provide different types of input materials. These regions are like in Tampere area and then in Helsinki. These are divided into HS, like home separated and post home separate streams. And both flow into a shared processing and analysis stage. On the right, the diagram shows material coming from Germany, which our partner Remondis provides, that represented as a home separated stream. It is also directed into the same analysis workflow. And on the bottom, we highlight two comparisons, one within Finland, another comparing Finnish and German materials. This image basically shows how STOPP evaluated different collection practices to understand how sorting methods and regions affect the quality of collected plastic packaging. So regarding the reusable packaging that I earlier mentioned, that it's conceptually very beautiful, but not very practical in real life. So reusable packaging must be durable, safe, and convenient. The project develops new durability protocol, washing efficiency models, and digitalized return system, all tested in real pilot. The work package 4 of the project develops durable materials capable of surviving many reuse cycles, including resistant to washing, heat, scratches, and mechanical wear. The accelerated aging protocols, it mimics real-life multiple use, because in this accelerated stress that be subject to the samples, we can make decisions way faster and more efficient. So the project created this accelerated aging methods, which the stress is heat, mechanical wear, and washing cycles. And these allow prediction of how reusable packaging behaves over long times, but very quickly. The outcome helps designers select material that maintains safety and integrity even after 50 to 100 cycles. Then innovation in sealing technologies for reusable food containers. The project develops a removable sealing layer that enable clean, peel-off sealing of reusable containers without leaving residues, solving a major barrier for large-scale retail and catering operations. Because, as you probably know, this reuse is one of the sources of microplastic. Then real-world reuse pilots in restaurant and retail across Europe. Our project ran large-scale reuse pilots in Finland, for example, in Kotipizza, some selected restaurants from Kotipizza, Switzerland and Belgium and France. These pilots test logistic, washing operations, consumer acceptance, packaging performance in real usage, and digital reuse system. Then behavior change and communication strategies to support reuse uptake. Our project tests behavior change strategies to increase consumer participation in reuse systems, including field experiments in restaurants and behavior change interventions. System-level tools for reuse implementation. The tools developed in VP6 of the project help brand owners implement reuse, and they are covering stakeholder alignment, pilot planning, roles, and responsibilities. Then, framework for reuse readiness and policy recommendation. The project policy recommendation emphasizes that durability standards, modular reuse packaging, digital identifiers, infrastructure needs, which are done all in work package 4. And then the societal engagement and behavioral shift. Behavioral change is key here. The project consumer research will help is helping aligning consumer perception with sustainable practices. The large-scale consumer behavior studies enabling targeted interventions. The work package 7 of the project conducts a large cross-country behavioral studies, so within Finland, France, Poland, and Spain, to understand how consumers interpret recycling, reuse, general waste, and littering in food consumption contexts. These insights allow designing more effective circularity interventions. Then field experiments validating behavioral change strategies in real restaurants. So the project runs real-life field studies in Swiss launch restaurants to test strategies that encourages consumer from single-use to recycled packaging, critical for circularity and for scaling reusable reuse models. Then multi-actor community as a tool for broad societal engagement. I will a little bit explain more about this community later on. And then brand owner bootcamp to accelerate industry-led behavior change. STOPP develops a brand owner bootcamp to help companies understand societal perception of reuse, evaluate consumer-facing communication strategies, design reuse ready packaging formats, and collaborate with reuse operators. For your information, the brand owner bootcamp will be kicked off in Paris Expo in May. And for those of you who are attending the Expo, it would be a great opportunity to come and attend that event from the stop. And then communication tools and campaigns to shift consumer habits. So the project creates targeted communication tools such as online interventions, reuse awareness campaigns, consumer-facing communication strategy tested in pilots, materials that clarify recyclability versus reusability. Reuse pilot generating real customer feedback and behavioral data. The reuse pilot example, Kotivica in Finland, generate real user data on return rates, motivations for participations, barriers like deposit level, convenience, cleanliness, and intervention effectiveness. These pilots contribute directly to understanding behavioral drivers of circularity. And then, last but not least, evidence-based policy recommendations that include behavioral components. The project poses a policy recommendation that integrate behavioral insights such as clear consumer guidance, harmonized communication, digital traceability to improve return rates, system-wide incentives supporting reusable and packaging. And yeah, of course, behavioral-based system integration into the eco-design framework. The project eco-design framework explicitly recognizes that successful circular packaging depends on us, on consumer behavior, and it requirements for usability, hygiene practices, clarity of instruction, and system evidence. So, this table somehow highlights the key challenges we face in making food packaging more circular and how STOPP translates each challenges into a concrete opportunity. So as I mentioned, contamination limits food grade recycling, but we address this through improved PP decontamination, NIA safety work, and cleaner feedstock enabled by better eco-design and sorting. Then complex packaging structures. Multi-layers are hard to recycle. So our opportunity here is monomaterial PP solutions with better barrier performance and full compatibility with existing recycling streams. The other challenge is collection and sorting variability. So different sorting systems create inconsistent recycling quality. Design for recycling helps us design packaging that matches real sorting condition, aligned with recyclers and simplifies structures. Then limited feasibility of reuse systems, which is another challenge. The reuse struggles with durability and logistics. Innovation like wear testing, optimized return logistics, and removable sealing layers make reuse more viable. And customer behavior challenge. Behavior is critical. So large-scale behavioral studies, field pilots, and engagement tools like multi-actor community and brand owner bootcamp help drive adoption. So to close, I want to highlight one simple message that circular food packaging becomes possible only when materials, systems, and people work together. No single solution is enough on its own. In STOPP project, we show that better material like monomaterial designs and safe food contact recyclates can dramatically increase the quality of recycling. We also demonstrated that more aligned system from collection and sorting to reuse loop make it possible to turn those materials into real circular flows. And importantly, none of this works without people. Our behavioral studies and field pilots show that when communication is clear and solutions are practical, consumers are more willing to participate. So thank you very much for your attention. Before I end up the presentation, I would like you to grab your phone and scan this QR and join our multi-actor community. So the project multi-actor community is actually a network open to everyone that is if you are interested to be a part of transition toward more sustainable circular food packaging value chain. When you become a part of this community, you will be invited for activities such as webinars, like workshops, and etc. And you will be like the first among people who get the results from the project, research analysis, and other technologies. So if you become a member, I just promise you that we are not bombarding you with a lot of emails. Just we send you two times email per year, and we update you about the project achievements and the next stages. Thank you very much for your attention. Pablo, back to you.
Thank you so much, Milad, for this valuable presentation. And yes, as Milad highlighted, you have there the QR code to join us the multi-actor community where you can follow up all the different updates of the STOP project. So now I think we have a few minutes to answer a few questions that our audience has asked. So, Milad, if you click on the question and answer, you can read it, but I will read it to inform the audience. So the first one is, what is the source of the observations regarding reusable packaging, and what do you base your conclusions on?
Okay, as I mentioned, the reusable packaging it's a very beautiful concept that brings the material in loop for a longer run. But practically, we have a lot of like issues with that. For instance, with the scratch test, we understood that over the time, a lot of like macro plastics originates, which is one of the big no-no from regulation point of view. What we did is that we tried to mimic all those like issues with the different tests, and we try to understand how we can decrease this like issues with better design. For instance, how we make the compound and for the reusable packaging, and how we use like sealing for that. This is about the safety of the material. And of course, this aging mechanism for the post-consumer are quite important to understand. This is one of the things that in Work Package 5, we followed that. All these washing protocols like wear behavior and sealing layer performance are the parameters that we have done in case of reusable packaging. And the other thing is that consumers are maybe not very eager to use the reuse packages in real life. How do we make like incentives for them? Uh, that's why we have the field studies in different countries. I mentioned that in Finland, I know that in Koti Pizza, in uh, like some of the restaurants, we made this campaign for reuse packages, and also at the moment, I think in K Market, if I say it correctly.
Great. The last one is, common issue with PP food grade recycling was always outdoor of the recycled granulates. How do you deal with this issue?
Yeah, that's a very good question. I mean that making the PP waste back to food contact recyclates is quite important in many aspects, like NIOS or odor. We are following the protocols from Recyclas, that it has different steps for decontamination of the material. One of the decontamination that we can mention here is the odor, because sometimes you can recycle the material, but when you smell it, it has some like unpleasant smell. These are done in different steps, and also our decontamination unit helps to remove the odor from the plastic material. Uh, but in my understanding, like this decontamination stage is one of the most important stages for removing like volatile, semi-volatile, and odor from the waste material.
Great, thank you. So we have finished in perfect time, so it's 12 o'clock, and I don't see any other questions in the chat or in the Q&A section. Oh, well, we have one last question. Maybe we have time to answer it. You mentioned that the recycling technology is at TRL4 now. When do you expect to apply to EFSA?
Yeah, I mean, within the project, from the very low TRL level of 2, we are reaching to TRL 4. But of course, to increase the TRL still, I mean that it takes a long time to go for the higher TRLs. To be honest, I don't know. It probably takes longer, longer time, but I don't have a like exact answer for this question.
Okay, and then we also have another question in the chat. When will your field pilots end? When do you think you will have the results and the interpretation from those pilots? Will they be communicated to the public in a journal publication?
Yeah, that's a good question. At the moment, um, we are doing the pilot in Switzerland, and most of the very good results of the project is coming up from now until the end of the project. And obviously, we provide all the results in deliverables. Most of the deliverables that are interesting for you are publicly available. It means that we will well, actually, it's Pablo's job that we will publish them in our website. And I think when the results are ready, you can follow everything about the result of those campaign from the related deliverables. As I mentioned, there are like a lot of important results of the project that are coming from now until the end of project because we have done a lot of like experiments, but the results the, the results are still coming out.
Yes, correct. So in the website, you have two sections. So you in the download section, you can find the public deliverables that are producing the stop project. And then within the multi-actor community submenu, you have a lot of information. For example, the results of the demand maps of the campaigns we use. We also have practice abstracts, which are summaries of some of the outputs that have been generated in the stop project. This will be published, more content will be published by the time that we generated more results. So for that reason, we invite you to subscribe to the multi-actor community so you don't lose the opportunity to be the first one in know these new results. Rather than that, I would like to thank you, Mila, one more time for your valuable presentation. I think we did a great session in a time and in a perfect timing. For the rest of the participant and the attendees, thank you so much for attending this webinar. There will be a new webinar that is happening next week on Wednesday. All the information is published on our social media, so you can register for the new webinar there, and hope to see you there. And we keep in touch. In the upcoming session. So thank you so much, everybody, and see you in the next session.
Thank you very much.